Okay. All right, code is IWD. Oh, type. Oh, IWD CXV. All right. So this first one. Oh, but this is the. Just kidding. That code is garbage. That's the wrong slide I clicked it for. You don't want to do a geometry lesson. Okay, you can leave that. I'm pretty sure it just kicked you out. Try this code instead. NFD VSR. All right, that's right. NFD VSR. There was side proofs today. All right. Okay, now here's a problem for you. This is a thinker. This was, I believe, the most missed question on the quiz, or at least the domain part of this was the most missed part of the quiz. So I'm going to give you 3 more minutes to struggle, right? See if you can come up with an equation that represents this box's volume, and then tell me the possible values of x I could plug into the equation. I'll give you 3 minutes to struggle before I just go over it and show you all what the heck I would, or at least one way you can do it. What I was looking for. That's what All righty. Okay, here's what we're looking for this problem. Find the volume of a prism. You do base area times height. All right, V equals capital B for base area times height, where this is the base area. This is for capital B. Our base is a square, so we just do the side length squared. The height is just x. So that's the formula for the volume. To find the domain, well, we know there are three constraints really, factually two. The height has to be a positive real number. Otherwise, like if the height was 0, then this would just be a sheet of paper and it wouldn't be a box. If the height was a negative number, that's impossible to make, right? We can't make a box as a height of -3 centimeters or what have you. So we know that the height, which is just x, has to be greater than 0. For the same reason, we know this side length and the width too has to be greater than 0. Of course, both of those are represented by the same thing because it's a square. So we know 18 minus 2x also has to be greater than 0. Again, the problem would be if you plugged in a value of x that did not satisfy this, then it would be impossible to construct a box that had 0 width or a negative number as its width. Then you need to solve both of these. Nice thing is one of them is already solved. To solve this one is 2 steps. Subtract 18. -2x is greater than -18. And divide by -2. Which gives us x is less than 9. Note that when you divide by a negative, it flips the sign from greater than to less than. So that tells us x must be greater than 0, but less than 9. So our domain is the numbers between 0 and 9. Again, I use parentheses and not brackets because those numbers aren't included. Yay? Yay. All right. That's all it is for that problem. And then the rest, I think, had you find the maximum, and you just type this into your TI-84 or Desmos to find the maximum. It then had you, I think, like make a table. Again, if it's in your TI-84, if you hit second graph, it pulls up a table of values and just other stuff that just use this equation. Basically, after this point, everything else is just calculator work. All right, questions? Anybody need more time to write? All righty. Okay, here's what we're doing today. We're going to do that easy peasy lemon squeezy. We're going to do that medium difficulty lemon middle of the road. This last thing is going to be on your own. It's really not that. It's just applying the 3 things we've learned so far to the stuff you already know about quadratics. So really, I mean, you could probably figure it out literally on your own, just trying to do the problems. But if you do reach a problem and you're like, I don't know how to do that, you can always just go to your textbook and you want to read the section 2.4 complex solutions of quadratic equations. It's got a great explanation of how you do everything. And then starting at example 6 are some great examples that go step by step on how to solve the problems like you would see on the homework. And there's even a checkpoint 1 for you to try to do on your own. And if you hit answer, it'll show you what the actual answer is. So you can see if you did it right. Another resource you can use is CalcChat. I don't think I've talked about that, but it's on the front of your book. It says with CalcChat. If you go to calcchat.com, and this is really, I'm talking about this not necessarily much for today's assignment, but for when I start going on paternity leave. Your textbook is like the first one in here. If you just click it, you can click any chapter, any problem. And like, let's say I'm looking at section 4, I'm looking at problem number 77. How do I do that? Or sorry, let's try 79. There you go. Hey, this is actually one. And it'll walk you through the answer key to that. Some of them even have video lectures, but if you scroll down, there's this Calc Chat Assistant. Now it's only open after school. It's open from 4 to midnight every night, that you can talk to somebody who will actually talk to you back and explain how to do the problems step by step. So when I'm on paternity leave and you ask the sub, hey, how do I do pre-calculus? And they say, I don't know, I'm just a sub. Then you go to CalcChat and you ask them. Or, I mean, there are other math teachers at TUS that could help you out. You go to Miss Ho, Miss Waters, Mr. Thompson. They know how to do all this stuff, so you can ask them for help too. All right. All right, let's get to it. So as I said, the first thing we're doing is just add, subtract, multiplying. Adding and subtracting is easy peasy lemon squeezy. If you want to add or subtract complex numbers, all you have to do is combine like terms. So for example, 3 minus 2i plus 2 plus 3i, I would just combine my real parts together. 3 plus 2 is 5. And the imaginary parts together. Negative 2i plus 3i is 1i. That's it. That's all there is to adding and subtracting complex numbers. Questions, or does anybody need more time to write? Okay, your turn then. Here you go. There's 3 problems. I'm going to give you 3 minutes. See if you can add and subtract all those complex numbers. Just leave it as so 4a minus 4. Oop, I just messed that up.
Mr. Lake,
Yeah,
do the signs change since there's like addition and subtraction signs, or do they not matter?
that is right. Yes. The first thing that I would do on most of these problems is distribute the negative sign. So like this one I maybe wouldn't, but you absolutely could rewrite that as 1 plus 2i minus 4 minus 2i. And then for this one, it would become 3 plus 2 minus 3i minus 5 plus I. For this last one, 4 plus 4i plus 4 minus I minus 7 minus I. Yep, you're absolutely right. And it's the sign changes that messes people up on these problems. So I might actually go through and distribute my negatives and get rid of all my parentheses because then it makes it a lot easier to do these. Who's got the first one? I roll a dice. Oh, yeah, you got it? Negative 3. Because 1 minus 4 is negative 3, and then the 2i minus 2i just cancels out. Who's got B?
I got negative 11 minus 2y.
Close. I think you got a issue with the sign. The minus 2i is right. But I think 3 plus 2 give you 5 minus 5. I think you may have switched the sign on that negative 5.
Oh, yeah.
There you go. Well, well. All right, who's got the last one? Abigail, you got it? 1 minus or plus 2i? Yeah. 4 plus 4 is 8, minus 7 is 1. 4i minus 1i is 3i, minus another I is 2i. Oh, that's kind of a weird circle. All right. See, these aren't too bad. Not too bad at all. And you know what else ain't too bad either? Multiplying. Multiplying is fairly straightforward. All you do is if you want to multiply two complex numbers, you just use the distributive property. That's it. I like combined like terms. So for example, if I have 2 minus I times 4 plus 3i, I would do 2 times 4, which is 8. 2 times 3i, which is 6i. Negative I times 4, which is negative 4i. And then negative I times 3i, which is negative 3i squared. All right, most people get that line and they do pretty good. There's always, gotta watch your negatives, right? The next line, I do get a lot of oopsies, or I'll get a lot of answers that look like this, 8 plus 2i minus 3i squared, and then they'll be like, I'm done. You're not done. I squared is really negative 1, right? And negative 3 times negative 1 is really plus 3, which I can combine with the 8. 8 plus 3 is 11. If you remember to do that last step, I think you'll be just fine when you multiply complex numbers. That I squared, remember, is really I is the square root of negative 1. I squared is negative 1. So -3 times -1 gives you +3, and you should be able to combine that with your other real number term to get 11. Or whatever. Yay? I know what you were thinking, Mr. Lake, 3 last time? That's too easy. Is that possible that we could do 4? And yes, it is possible. Does anybody need more time to write before I clear this? Okay, 4 this time. Try all 4 of these. I'll give you 4 minutes. Really getting your money's worth today. When you were thinking, hey, it's a snow day, am I gonna actually miss anything if I just stay home today? Oh yeah. 7 on your own problems. Okay. Looking at the pair deck, I think we're in a good position here. So if I distribute these, first one, you should got -10 plus 15i. Second one, 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 6 is positive 6i. 2i times negative 2i is negative 4i squared. Notice that the middle two terms cancel. This is really negative 4 times negative 1. So it's really plus 4, and 9 plus 4 is 13. If I distribute here, I get negative 4i plus 20i squared. But again, that's really negative 20. So I'd write that as negative 20 minus 4i. Now I know what you're thinking. Mr. Lake, what if on my paper I wrote negative 4i minus 20? Is that okay? I just really want to think, is that the kind of person that you want to be? The answer is no. You want to put the I second, right? That's how they always are written. Okay, so just put the I second. Think of it like this. If the I's in the back, then it's always looking forward. And don't you want to be looking forward, not like trapped in the past, always, focusing on your past? Or do you want to be a forward-looking person? Right? There's a lot at stake on which order you put them in. So I'm going to tell you, put the I last. For this last one, 3 plus 2i squared is just 3 plus 2i times 3 plus 2i. If we distribute, you get 9 plus 6i plus 6i. Ooh. Plus 4i squared. Again, this is really becomes negative 4. So you get 9 minus 4 is 5. 6i plus 6i is 12i. Yay. All right. So notice in B that multiplying 3 plus 2i times itself when the middle symbol is changed resulted in a real number. We're going to use that. We're going to use that so much you're going to be sick of it by the end of this section. Because if I want to divide two complex numbers, I have to use their conjugates. Well, what's their conjugates? So that's what this slide is about. If I have a complex number a plus bi, its conjugate is a minus bi. And the reason why I care about that is because if I multiply a plus bi times a minus bi, I get a real number, which is a squared plus b squared. I got to do a proof of that down here. You do not need to write the proof. Here's the proof. It's a really easy proof to do. If I multiply these together, a times a is a squared. A times negative bi is negative abi. Bi times a is positive abi. Bi times negative bi is negative b squared I squared. Negative abi plus positive abi cancel out. I squared is really negative 1 times negative b squared becomes a squared plus b squared. Ba, 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 ba. So ultimately, all this is a shortcut. If you are multiplying something by its conjugate, you don't have to go through the distributive property and do it. You know that the answer will just be whatever a is squared plus whatever b is squared. For example, I plus or 1 plus I, its complex conjugate would be 1 minus I. Again, all I do is I change the symbol in the middle from a plus to a minus. If I multiply 1 plus I by its conjugate, 1 minus I, Again, I could do the distributive property that works absolutely. Or I could just write A is 1, B is 1. So the answer to this is just going to be 1 squared plus 1 squared, or 2. So you don't have to end up doing the distributive property at all. This shortcut will get you the answer fairly quickly. The other great thing about this shortcut is it takes a complex number and it makes it into a real number. All right, good to go on? Okay, your turn then. Let's just make sure you understood what I just said. I'm just going to give you a minute. Write the conjugate of 4 minus 3i and then multiply them together. Okay, hopefully this is what you got. The complex conjugate of 4 minus 3i would be 4 plus 3i. If I multiply those together, if you use the distributive property, again, that's 100% okay. But we know A is 4 and B is 3. 3. So the answer is just going to be 4 squared plus 3 squared, which is 16 plus 9, which is 25. So no matter what method you use, you're going to get the answer 25. It's just a shortcut, saves you some time. All right. Again, the reason why we care about that is because if I want to divide two complex numbers, how I will actually do that is I will multiply by the conjugate of the denominator. So if you think back to fractions, if I want to multiply two fractions to get, or divide two fractions, I flip and multiply, right? I multiply by the reciprocal instead. For division of complex numbers, we do a very similar thing. Instead of dividing, we multiply, but we multiply not by the reciprocal, but by the conjugate instead. So for example, if I want to divide 2 plus 3i by 4 minus 2i, I would find the conjugate of the denominator, which would be 4 plus 2i. Remember, all I do is change the middle sign from a minus to a plus. And I'm going to multiply that by the numerator and the denominator. And so if you do how to multiply complex numbers from the slide we did, 2 slides ago, 3 slides ago, that's all we're really doing here. Just multiplying a bunch. For the numerator, 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. 3i times 2i is 6i squared. For the denominator, again, I could do the distributive property, but I know since they're conjugates, the answer is just going to be 4 squared plus 2 squared. All right, then I want to simplify this. In the numerator, remember I squared is -1, so this is really -6. 8 minus 6 is 2. 4i plus 12i is 16i. 16 plus 4 is 20. All right, this is still not finished yet. I could simplify this for more because all three of these numbers are divisible by 2, right? So there are actually 3 ways I would accept the answer to this problem. I would accept 1 plus 8i over 10. That's fine. Or if you went one step further and said that this was 1/10 plus, now I wouldn't do 8/10, I'd do 4/5 I, that would be fine. So if I went ahead and did the division, that'd be okay. Or if you don't like fractions, I would accept 0.1 plus 0.8 I. And actually, in this case, WebAssign will accept that too, because that's an exact decimal, right? I'd have to round to get that. It's exactly 0.1 and exactly 0.8. So I believe if you type any of these 3 into WebAssign as your answer, it'll count it correct. If it doesn't, you can come back on Wednesday and tell me that I'm a liar, and my pants are on fire. But I think it accepts all 3. Pretty sure about that. 75% sure. All right. The only thing on the homework I haven't lectured over is how to do these. Oh, that's just another practice problem. Is how to do these quadratics. But again, you're just using factoring or the quadratic formula. The only difference is when you do the quadratic formula or solve it algebraically, you're going to have a square root of a negative number. But that's not a problem for us anymore. Square root of a negative number is just a square root with a 9. That's it. But you can go and read through the example 6 to see how they deal with that step by step. And they just take this negative, put a 9. That's all there really is to it. All right, and then we'll do 2.5 on Wednesday and 2.6 on Thursday, and that'll be the week.
Hey, Mr.
Hey.
Lake.
Yes.
I requested extensions on all my homework on the which.
Okay, I'll put them in. I'll put them in right now.
All
Let me
right,
stop sharing.
appreciate you.
All right, have a good one, everybody.
See you.
Oop. All right, bye.